Hello, welcome to Panel Educate. In this mathematics series, we'll be looking at algebra processes, and I'm expecting that at the completion of this video series, you will be able to simplify, substitute, expand, and factorize algebraic expressions. We'll also be looking at how you can determine whether an algebraic expression is a perfect square, and also how you can determine what must be added to make an algebraic expression a perfect square. So let us look at what algebra really is. Algebra, as we know, is that branch of mathematics that use letters in place of numbers. So in everyday affairs, we come across expressions involving quantities like 2 chairs, 5 tables, 4 books, 3 men, 8 women, etc. So if we take W, X, Y, and Z, maybe we use W, we use Y, we use X, we use T. If we look at all of these to represent, for example, we will use 5 tables to represent all these. We're going to have expression like 5T. We're going to have expression like maybe 2 yams. We're going to have expression like 3 umbrellas, that's 3U. So we can also have combinations like maybe 5 tables plus 2 yam, okay, probably plus 3 umbrella, okay. So we can also have all these combinations. So these expressions and their combination are called algebraic expressions. So all these expressions and their combination are called algebraic expressions. So we can also connect all these algebraic expressions with equality sign to form other algebraic statements. For example, we can say 5 table is equal to 8, right? So we can use all these equality. You can say 5 table, okay, plus 5 chairs is equal to 20. So we can also connect, can also use the equality sign to form other algebraic statements. So we'll be looking at how we can simplify and also use substitution of this expression in what we are doing. Okay, so let us look at simplification of algebraic expression. How do we simplify algebraic expression? Okay, like I said before, for example, we talk about probably 3x, we talk about 7t, okay, 2c, the chairs, and on like that. So all of these, we call them algebraic expression. So the expression that you see like this, 3x, 7t, 2c, or 2x, 5y, all these expressions, they are called terms. Okay, this one is like a terms, maybe 3x is in term x. This one is in term t. Also, this one is in term y. Term c. This in term x. This in term y. All right. So what do we do when we have 3x? 3x and 5x, they are in like terms. All right. So if you have 70, maybe another 5t, they are this also in like terms. We have 2c, then we have 5 or 8c. So because c is a c term, this is a c term, they are in like terms. So you can group all these terms together. So what we do is that in simplification of algebraic expression, we collate the like terms. We collate like terms by grouping them together before we perform some arithmetic signs on them. So can perform arithmetics like subtraction, addition, division, or multiplication on them. So let us quickly look at examples. For example, in the example 1 here, we are asked to simplify the following expression. As you can see, we have 7x plus 5x minus 2x minus 4x. So and what do we do here is that 7x plus 5x, they are positive terms. So we just do 7x plus 5x, they are positive terms. So we have minus 2x, all right, minus 4x, they are negative terms. So once you add it together, this one will give you 12x, and this one will give you a minus 6x. So your answer will be 6. The answer will be 6x. All right. So if we look at further examples, we'll say that 8p minus 3p, we're given 8p minus 3q, that's plus 4r, okay, minus 2p plus 6q plus 8r. So if we start grouping in like terms, we'll look at p. Let's just take all the p's together. So we have 8p, okay, followed by minus 2p, okay, then we have minus 3q, okay, followed by another 6q, all right, then we have this plus 4r, okay, then followed by 8r, all right. So if we do this, we're going to have 6p, all right, plus 3q plus 6q, which is going to give a positive 3q, while we have plus 4r plus 8r, it's going to give us a positive 12r. So that is how we can group in like terms. All right, so let us look further on how to simplify algebraic fraction. All right, so if you want to simplify algebraic fraction, we just need to find the common denominator known as the LCM and multiplying the fractions by it. For example, in this example, so let us look at 4x, over 5, then plus 6x over 5. So the LCM for this is 5. All right, so 5 in 5, that's 1. 1 multiplied by 4x will give you 4x. Same thing with this, 5 in 5 is 1, plus 5 by 6x is 6x. So if we do 4x plus 6x, it's going to give 10x over 2. So you can still divide this further. 5 goes here, 5 goes here, 2. So it's going to give you a 2x. All right, so here also, we look at the LCM of the denominator. This is the denominator, and the LCM of this is hy. Okay, so what do? We take 4y away from hy, so we get 2. 2 multiplied by 8 is going to give us 16. 8y in hy is going to give us 1. 1 multiplied by this is going to give us minus 2. So we have 14 over 8y. All right, so we can actually divide this. 2 goes here, 7. 2 here, 4. So our answer is 7 over 4y. Okay. Now, let us look at the substitution. All right, so in this particular one, what we're trying to do is just like when we're giving certain expressions. So we know in algebra, we know that letters in algebraic expressions stand for numbers. So sometimes it is desirable to find the values of this expression by putting back or substituting for the letters with numbers. So it's very much possible that we're giving this kind of expression and we're giving the x. For example, we are giving x to be equal to 3, then y to be equal to minus 4. So we just need to substitute this into the expression that we are given. So how do we do that? So if you do x here, we are given 6x plus 5y. So I just need to substitute 6x is 3, all right, plus 5, and y is minus 4. So this one will give me 18. Then 5 times minus 4 is going to give me minus 20. Then you are going to give me minus 2. All right, so the same thing goes with the other one that we're giving. For example, you have 6 into x minus y plus 4 into x plus 3y. So don't forget that we're given x to the 3. So we'll do x to 3. Okay, then minus 3 minus, what is our y? Our y is minus 4. Okay, then we have plus 4 into x, which is 3. Okay, then we have plus 3 into y, which is minus 4. Okay, then this one, 3 minus minus 4 is going to give us a 7. So 6 is going to give us 3 plus 4, that is 7. All right, so we have plus 4 into, we have 3. This one is going to give us, this one 3 times minus 4 is going to give us minus 12. All right, so this one is going to give me 42. Then plus 4 into 3 minus 12 is going to give me minus 9. So I have my 42 plus 4 multiplied by minus 9 is going to give me a minus 36. So minus 36, and it's going to give me a 6. All right, so that is how we can substitute the value of the terms that we're given into the expression and get the answer. All right, so let us look at expansion and factorization. So algebraic expressions can also be expanded or factorized like the basic rules of arithmetic. So it's just the normal arithmetic rules we can expand. For example, if we're given a 3x plus 4, okay, into 2x minus 5. All right, so we just do this 3x multiplied by this. Okay, it's going to give us 6x squared. You take this one again, multiply it by this, everything here. So 3x multiplied by minus 5 is going to give me a minus 15x. Okay, I'm going to do this plus 4 multiplied by 2x. It's going to give me a positive 8x. All right, so I'm going to use this plus 4 multiplied by minus 5 plus 4 multiplied by minus 5. I'm going to give me a minus 20. All right, so if I do my calculation, try to get minus 15x plus 8x is going to give me minus 7x, then minus 20. All right, so that is how we can expand this. So in expanding this, it's going to give you this particular answer. Same thing goes with this. X multiplied by x, it will give you x squared. This x again multiplied by plus 2y is going to give me a positive 2xy. Plus 2y multiplied by x is going to give me a positive 2xy. Then this plus 2y multiplied by plus 2y is going to give me a positive 4y squared. So if I put everything together, this is going to give me x squared. 2xy plus 2xy is going to give me 4xy. Right? So then plus 4y squared. That is what that one is going to give me. All right, so we'll also look at the factorization. Let us look at the factorization. All right, so, and in this particular one, we'll be looking at how we can factorize by taking out common factors. We'll also look at how we can factorize by grouping of terms of the expressions. We'll also look at how we can factorize quadratic expressions, and we'll look at factorizing perfect squares, and finally we'll also check how we can factorize difference of two squares. All right, so let us quickly look at how we can take out common factors. For example, if you are given 24x minus 6y, the common factors here, which is the highest common factor for the two, is 6. All right. So we have the highest common factor of 24x and 6y to the 6. That's the highest common factor. So that means that's the highest number you can use to divide the two. All right. So we'll take 6 out. Then 6 and 24x is going to give us 4x, and this one is going to give us minus y. All right. So that's how we can take out common factors when we are factorizing such expressions. So we also look at grouping of terms. This was discussed earlier. Factorize the following: 5ax minus 5bx minus a plus b. So we can regroup like 5ax minus 5bx can be grouped together. Then minus a into 5ax minus 5bx minus a is 5bx minus a plus b. Alright, so once you group these 5ax minus 5bx, alright, group together, one should have a minus a. Alright, so you can also have, a, then this one will be a minus b. Because in fact, if we multiply this one by minus times a, is going to give you a minus a. Minus by this one is going to give you a positive b. So this is what this is going to give you once you factorize it out. Then we can take 5x out of this place. Then this one will remain a. Then this one will be minus b. Then we have a minus, just like a minus 1, and a minus b. Alright, so we look at it together, 5x minus 1. Alright, minus 1. Then into bracket a minus b. So if you simplify this, it's going to give you this particular expression. Alright, so that is how that one is. Let us look at how we can factorize by quadratic expressions. How we can factorize by quadratic expressions. Okay, so let's look at this. X squared minus 8x minus 33, we are given an x squared minus 8x, then minus 33. Alright, so what you need to do here is that we multiply this minus 33 by this particular x squared, so to give a minus 33x squared. Alright, so then we're going to look at what we can use. If we multiply it together, it's going to give us this. And if we do addition or subtraction together, it's going to give us this. So if we have minus 11x, that is 11 multiplied by 3, we know that 11 multiplied by 3 is 3. So minus 11x, then plus 3x. Alright, so plus 3x times minus 11x is going to give us minus 3. Then minus 11x plus 3x is going to give us minus 8x. So then we have what we're looking for. So we replace x squared. So this minus 11x plus 3x, okay, we'll replace minus 8x. Then we'll now put our minus 33 here. So we expand further, x into x, right, minus 11, okay. Then this one is a plus 3. Then we have x, then minus 11. So with this, we can have x plus 3, all right, into x minus 11. All right, so that is how we can do that by quadratic. How we can factorize this by quadratic expression. All right, so let's look at another one. We are given y squared plus 8y minus 20. All right, the same thing is going to happen. Minus 20 multiplied by y squared is going to give me minus 20 y squared. All right, so the factorization that I can use here that can give me something close to this, I can use 5 times 4, 10 times 2, that is 20. Is there another thing that I can use to multiply 20 times 1, that's 20. All right, so 5 times 4, if I do any arithmetic like addition, subtraction with this, it can give me this. But this particular 10 and 2, if I do anything on it, can give me 8. Alright, so I can do that's 10 and 2. So I can do a 10y, okay, then minus 2y, right? So 10y minus 2y is going to give me this, and 10y multiplied by minus 2y is going to give me this. So I can replace this now with this. I can put this one as this now. So y squared plus 10y minus 2y, this has replaced this, then minus 20, then a y, into y plus 10. Okay, same thing, that's y squared plus 10y, then minus 2. If I put this minus 2 out, it's going to give me y minus 2 times y, then this particular one will give me a positive 10. Because if I do minus 2 multiplied by 10, it's going to give me minus 20. So I have a y, then this particular one, y minus 2, alright, and I have a y plus 10, alright. So that is how we can factorize by quadratic expression. Alright, so let us look at difference of two squares. Alright, so if we have expression in form of this, okay, we have expression in form of this, x plus y, x minus y. So if you factorize that out, it's going to give you, we have x plus y into x minus y. So if you factorize that one out, x multiplied by x is going to give you an x squared. X multiplied by minus x squared is going to give you minus xy. Okay, plus y multiplied by this is going to give you a plus xy. Then plus y multiplied by this is going to give you a minus y squared. Alright, so you're going to have s squared minus y squared. Okay, so if you do the same thing, and don't forget that we have x plus y, x minus y for this, anything x squared minus y squared, which is giving us a difference of two squares. You have a difference of two squares. So if you have also x plus y into x plus y, alright, what is this one going to give you? X multiplied by x squared is going to give you x squared. X multiplied by this is going to give you plus xy. Then this one multiplied by this is going to give you plus xy. Y multiplied by this is going to give you plus y squared. So this one also is going to give you x squared plus 2xy plus y squared. Alright, so let us look at certain examples. So we know that x plus y, when you have x squared minus y squared, that is what is called difference of two squares. And you are going to express this thing as what? X plus y into bracket x minus y. So let's look at a certain example. For example, you are given 25y squared, alright, minus 1. Okay, so now how do you make it difference of, you know that this is actually a difference of 2 squared. So you know that this can be 5y all square, then minus 1 all square. Alright, so this is just like a s square, then minus y square. So what do? We just pick this. So you know this one is going to give me x plus y into x minus y. Alright, so this one now I just do 5y, which is this, okay, plus 1. Okay, then I do another one, 5y, okay, then minus 1. Okay, so that is how to factorize difference of 2 square. Alright, so you can also do the same thing to So you can also do the same thing for this particular example. We're given a q plus 8, all right, all square minus q plus 5 all square. All right, so this difference of 2 square, as if you have x square minus y square, and it's going to give me x plus y into bracket x minus y. So that's what I'm going to have. So now my x here, okay, is q plus 8. Okay, that's what I should do. Then plus y, which is q plus 5. That's the first one. Okay, then the second one, I've used a positive. I'm going to do the same thing. I'm going to have a q plus 8. Okay, then minus q plus 5. Alright, so that is what I'm going to have. So a q plus 8, this one is going to give me q plus 8 plus q plus 5. Okay, and I'm going to have another one into q plus 8. This one, to multiply this minus out, it's going to give minus q minus 5. Okay, so I'm going to have a 2q like times, okay, plus 13. Alright, and this one, q minus q is going to give me 0. 8 minus 5 is going to give me 3. Okay, so I'm going to have 3 here. So if I multiply 3 with this, I can get my answer, but I'll just leave my answer as 3 into 2q plus 13. Or I say my answer is 6q plus 39. Alright, so that is the difference of 2 squared. So let us look at factorization of perfect square. Alright, so when I was mentioning the other time, when I was talking about the difference of 2 squared, I talked about certain expression which I also want to state again here. For example, if you have a plus b all square, okay, then you're going to have a plus b like this. Then what's going to give you is a square plus 2ab plus b squared. Please take note of this positive here. Throughout, positive throughout. But if you have a minus b all square, right, it's going to give you, after expansion, you're going to have a square minus 2ab then plus b squared. Don't forget a plus b all through. A plus b plus b is going to give you a positive throughout. It's going to give you a positive throughout. But for a minus b, you're going to have a minus 2ab here. And only you're going to have a positive b squared here. Now, this expression of a minus b all square or a plus b all square, they are called perfect square. Perfect square, which is different from the one we did earlier on the difference of 2 square. This one is called a perfect square. Alright, so now we want to determine the following expression if they are perfect square and want to factorize where possible. Okay, so now let us look at it. A square plus 6ab plus 9b squared. Don't forget what I said the other time. You just multiply this one by this. So we're going to have 9b squared, a squared. Alright, so we're going to look at what we can use. We can multiply together. So if I do 3ab, alright, multiplied by 3ab, it's going to give me 9b squared, a squared. Alright, so, and if I add it together, it's going to give me 6ab. Alright, so once I do that, I'm going to have a squared plus 3ab plus another 3ab plus this is 9b squared. So this is going to give me a into a plus 3b. Then I'm going to have plus 3. This is common. B is common here, plus 3b. I'm going to have a plus going to be 3. And that will be what? 3b. Okay, so that's alright. So then you have a plus 3b, okay, into a plus 3b. Okay, there's some things that I want us to take note in this expression. I want to know why, if this is perfect square or not. Don't forget, in the equation that we are given on a perfect square of a plus b, we have a, so we have a square, the 2 times that we have a square, and we have another b square. Then the square root of a is a. Then the square root of b square, square root of a square is a rather, and the square root of b square is b. Okay, so then we can either have plus or minus a, or we can have plus or minus b. Okay, then this one here we can have is twice as square root of this, twice a or b. Okay, so in this one that we are given, in this particular one that we are solving, all right, so you will discover that the 2 terms that we have here, they are a square and also 9b square. All right, so these 2 terms are perfect square. Why? Because their square roots are, this one can, square root of a square will be plus or minus a, and the square root of 9b square will be plus or minus 3b. Okay, then the remaining one here is 6ab, and this is ab. Don't forget 2ab that is there. We can say 2 into bracket. We have a, which is the square root of this can be a. Then we have this particular one, 3b. Okay, so we can have this, or we can have 2 into brackets minus a, or minus 3b. You can also have that thing. You can also have that one also. So what it then means is that this expression is a perfect square. If we factorize this one is going to give us, if you multiply this one together, it's going to give you 6. It's going to give you what? Alright, 6ab. If you do all this one together also, it's going to give you 6ab. Okay, so it shows that this expression is a perfect square. And by the time you factorize it, you see that it's a plus 3b all square. That is it. Now let us look at further examples. Alright, so let us look at okay, b square, alright, minus 6b, b square minus 6b plus 9. Okay, so we're still looking at if the expressions are perfect square. Alright, we're still looking at if the expression is perfect square, and we should factorize if possible. Now let us look at the expression that we're looking at here. We have a b square, alright, and we have a 9, alright. So this 9 can give us a 3 square. Alright, so this b square can give us plus or minus b, that is square root. And square root of 9 will give us plus or minus 3. Okay, so it means that the 2 terms that we have, the square root are this. So that means these two terms that we have here, they are perfect square. Alright, so the only one that we now have is the minus 6b, and the minus 6b, don't forget, we can have when you have a minus here, okay, so that means we can have a minus 2 into, don't forget the square root of it, this one is a b. Alright, so we can have a b here, a positive b, and we can have a positive 3 here. So also we can have minus 2 into a minus b, okay, then sorry, rather 2, okay, so we can have yes, we can have a 2 into this. Where is the other one, which is a minus? This is the minus. We can have minus b here, we can have minus 3 here, which is also minus 3 here. Alright, so if we have this one together, multiply this one, this is going to give us a minus 2, that's a minus 6, a minus 6b. Alright, okay, so if you do this one together, this will minus as for positive 3b times this is going to give you a minus 6 b. So it means this expression is a perfect square. So what we can then do is to now factorize this 9b squared going to be a minus 3b minus 3b. Okay, so we can then have b squared minus 3b minus 3b, which we have used to replace this. Don't forget, this minus 3b plus 1 is going to give you a positive 9b squared plus 9. Then it's going to have b into b minus 3, then minus 3 into b minus 3. So we have b minus 3 to bracket b minus 3. So b minus 3 all square. Alright, so that means this particular expression is a perfect square. So what we need to do is to check this, the two expressions that can be squared, if they actually are perfect square, by taking the square root of the two of them. Then looking at the other expression, the other terms, which is the other b terms that is inside the equation. So let us look further to solve what must be added to the following expression to make them perfect square. What can we add? So we are given a square plus 6a. Okay, so what must be added? Now, if you have a positive here, then what should be on your mind is that we also have like a plus b all square. Alright, so if you have a plus b, don't forget you're going to have a plus 2ab plus b squared. Alright, so that's why you have this. Okay, so now what must we add? So a perfect square for this, the other term that we need could be like x squared. Alright, so if we do this, we know that this particular a squared, okay, the square root is going to give a plus or minus a. This x squared, square root is going to give a plus or minus x. Okay, so if we check this 6a now, okay, in respect to this, alright, we're going to have this 2ab, we're going to have it equal to this. So we can equate this. We can actually equate this, alright, to a square, right, okay, plus, because we can replace this one as a plus x. Alright, so it's going to give us a plus 2ax, then plus x squared. So this one can give us a squared plus 2ax plus x squared. So now what do? We just equate them together to look at what must be added. Put them together. This 6a, a squared is equal to a squared, x squared is equal to x squared. 6a, alright, is equal to 2ax. Alright, so a can cut here, 2 can cut here, we have 3. So we have x is equal to 3. So if x is equal to 3, then our s squared will be 9. So that means what we need to add to this equation for it to make a perfect square is 9. So we're going to have a squared plus 6a plus 9. Okay, so let us look at another one. We have this one, x squared minus 10x. Okay, so if you have x squared minus 10x, definitely what you have, don't forget, is going to be x minus something, maybe x minus b to x minus b. All right, so we're going to have x squared minus 2bx. All right, don't forget. Then we're going to have a positive b squared. So once you have a minus here, as you have here now, definitely you should know that what you're going to use is this particular form of expansion. So now what do we do? X squared minus 10x. So we're going to have, so what we want to add here is a squared. So what we're going to have is x minus a, right, into x minus a. So if you do that one, it's going to give you x squared minus 2x plus a squared. All right, so what we then need to do is to equate it together. This minus 10x is equal to minus 2ax. All right, so x minus 10x is equal to minus 2ax. So x cuts this. All right, so a would then be 5 minus 2 here 1. This one here, this 5. So a is 5. So if a is 5, then a squared is equal to 25. All right, so what we need to add to 25, to add to this expression, is actually 25. So let us quickly look at this certain expression. If we are given this, all right, without this, all right, we have to express that one also. Then what we need to add is to just add plus k square, you know, to complete the square. All right, so now the expression for a squared, the square root is 2a, then k squared, the square root is k. So 2a plus k, which is going to give you this expression, if you expand it, it's going to give you 4a squared plus 4ak minus plus k squared. So if you equate it with this, all right, 4a squared is equal to 4a squared, k squared is equal to k squared, then 8ab is equal to 4ak. If you equate it, you're going to have k is equal to 2b. All right, so we have k squared will also be 4b squared. So if we put it back into the expression, that particular expression there, if we put it back into this particular expression, it's going to give you 4a squared plus 8ab plus 4b squared. So if you factorize this, you're going to have 2a plus 2b all squared. So if you expand, it's going to give you this particular one. All right, with this, we've come to the end of this video series on algebraic expression. Please subscribe for more educative videos from Penel Edu Center, and we also want to have your feedbacks. Send us email on questions that you may have as a result of this lesson. All right, so we'll see you more in the next video lesson. I hope this has been very informative for you. Thank you for watching. Bye.